here we're going to have an hydroxy group here, right? Then here we're going to have hydrogen here. You're going to have hydroxy group here. Then we're going to have, then hydrogen is here. Then here we're going to have hydroxy group here, and also what, we have hydrogen here. Don't forget that this hydroxy group, whenever it is placed on the right side, you are having D-ribose, right? You are having D-ribose, and whenever it is placed on the right hand side, you are having what? You are having L-ribose, right? Which is actually refers to as what? Level rotatory, right? Now let's just go ahead and what, and fill the rest with what? With hydrogen. Check if the bond is what? Is right. We are going to have OH here. We're going to have hydrogen here, right? And also what? Hydrogen is here, right? Now from there, now I want you guys to look at this very well. This is referred to as ribose because it's our 5 carbon atom. So 5 carbon atom with what? With an aldehyde functional group here is called what? Ribose. Then from there, we can actually name it using IPAC. I know you want to name that, so kindly name this one and actually drop it in the comment section below. Now let's move to what? To 6 carbon atom, which is actually what? Aldo sugar, the common one that we have. And the common one that we have is actually what? Glucose. Glucose is the most common and also, let me simply say, abundant monosaccharide that we have. And it is referred as what? As glucose. Now, let's simply draw the structure of what? Of glucose in both Fischer form and also what? Haworth form. Okay, before I forget, I actually need to draw the structure of what? Of ribose as well. Ribose as well, because it is 5 carbon atom, right? Since this 5 carbon atom, it is 5 carbon atom, which is ribose, right? So we have to draw the what? The cyclic form of it. So we're going to simply have the furan form. This is a furan form. We're going to have a furan form, right? So this is a furan form. Then you have something like this. Can you see it now? So from there, you can actually what? You can actually have an OH here, right? You have an OH here, right? You have H here. You are going to have OH here. Then followed by here as well. Then you're going to have OH. So here you're going to have, let's count the carbon. 1, 2, 3, 4. The carbon is actually 4 here. But what we are going to do is that we're going to have another one here, which is making 5. So we're going to have our hydrogen here. You can have OH here, right? You're going to have what? Hydrogen here. You're going to have hydrogen here. So you're going to have hydrogen here, right? So that's basically the structural form of ribose, right? Of ribose. So here, let's just compare it with the straight chain form. Straight chain form, you're going to have, this is carbon here. Carbon is here, right? Carbon is here. 1, 2, 3, 4, and 5. We're going to have OH is here. Hydrogen is here, right? And also what? Hydrogen here is here. So this carbon is actually what? This one that you're seeing here. This one that you're seeing here represents this carbon here, which is the carbon number 5, right? Then carbon number 4, you're going to have, which is this. You're going to have OH actually here. OH should be here. You're going to have OH. OH should be here. You're going to have OH here. So from there, carbon number 4, you're going to have OH and also what? You're going to have H here, right? Then apart from that, you're going to have this carbon number 3, you're going to have OH at this side and also what? H at this side, right? Then carbon number 2, you're going to have OH here and also what? H at this side. Then carbon number 1, you're going to have what? You're going to have, this is what you are seeing here. You are seeing this is oxygen and also what? This bond, this carbon here is called the anomeric carbon because it reacts with what? With the terminal hydroxy group. And the terminal hydroxy group here is actually what? Is actually this case that you are seeing. So that shows that instead of we to have hydroxy group here, we're supposed to have it to what? To be hydrogen actually. It should be hydrogen. It should be hydrogen. Because the hydroxy group on this carbon number 1, this is 2, this is 3, this is 4, and this is what? This is 5. Right? So now in that case, we're going to have hydrogen here. So this carbon number 1 is what? Is the anomeric carbon. It has actually reacted what? With this guy here, with the carbon number what? Carbon number 4, which is the what? The terminal carbon. So from there, we're going to have our functional group here, which is O, and also what? Our aldehyde. So this is the Fischer projection formula, and this is what? The Haworth projection formula for what? For ribose. Right? Now let's move to what? The 6 carbon atom, which is what? Which is glucose. Let's move to the 6 carbon atom, which is the glucose. And let's go. So one thing I want you guys to understand here is that whenever you are using Fischer projection formula, you actually want to show the stereochemistry of such monosaccharide that you want to draw. But whenever you are drawing using the Haworth formula, you want to show the reaction of the monosaccharide, because the reaction of monosaccharide can be best represented in Haworth form compared to what Fischer form. Because in the case of Haworth form, it will basically show the position, the orientation of the glycosidic bond that is found between the monosaccharide. Now let's move to the glucose. Glucose is actually what 6 carbon atom, right? And the structure is done as an aldose sugar as well. We're going to have C double bond O here, right? They are going to have hydrogen is here. We're going to have carbon is here. OH is here, right? Then we're going to have what hydrogen to be here. Then followed by we're going to have another carbon here. On this position, we're going to have the hydroxyl group to be here, right? Then we're going to have hydrogen here. Then go ahead again. We're going to have another carbon, right? We are going to have this to have OH, right? Then I'm going to have another what hydrogen is here. So we are going to have 1, 2, 3, 4. So this is 4 carbon atom. So we are going to have it up to 6, right? So here we are going to have the terminal alcohol here. Terminal alcohol is actually found in carbon number 5. We're going to have hydroxyl group here. They're going to have OH here. We're going to have what another hydrogen here, another what hydrogen here. So this is the structure of glucose. That is the Fischer formula of what of glucose, because it shows the orientation, that is the position of the bond, everything. The stereochemistry of this compound is shown by what by Fischer Projection formula. Now in the case of Haworth Projection formula, the most stable form of Haworth, don't forget that Haworth actually make use of what of furan and also what pyran for its structure, right? Then the most stable form is actually what the pyran form for glucose. For glucose, if you are drawing glucose using Haworth Projection formula, the most stable form is what is the pyranose form, which is the pyran form. But for fructose, it is furanose form. I'm still coming here. Now let's just draw the structure of glucose in Haworth form. We're going to have oxygen here. We're going to have something like this. You have something like this, right? So first thing you need to note is the carbon. We have carbon 1 here, carbon 2 here, carbon 3 here, carbon 4 here, carbon 5 here. Then you're going to have another one here, right? So in that scenario, we're going to have another one here. We're going to have another one here, another one here. This is a bond. A bond is here, right? You're going to have another one here. This is C, H is here, right? And also what? OH. Now this carbon simply represents everything that is here. The carbon that is here. That's this carbon, right? Then from there now, we actually need to fix in the orientation of the hydroxyl group and also what? And also the hydrogen. Now this is carbon number 1, which is also refers to as what? The anomeric carbon. And the reason why it's called the anomeric carbon is because this bond that you are seeing here, this O bond that you are seeing here, can actually switch. Can actually it can orientate, like switch, right? It can switch the position of what of hydroxyl and also what the hydrogen group that are present here. Now look at this. We are going to have OH here, right? We're going to have what H here. The reason why it is referred to as anomeric carbon is that now let's suppose there is a carbon here, right? If the carbon is here, we're going to have a bond, one connected to this guy, and the other one connected to this guy. Then the one connected to what this carbon here, and also what hydrogen here. Now this carbon oxygen that you are seeing here is actually from what? From this functional group. It's actually from this functional group. And there is one thing I'm going to explain in a separate video. What is meant by EMIL FISCHER and also EMIL FISCHER. I'm going to explain it in the next video because it's very, very important. Now, one thing is that EMIL FISCHER is formed whenever the aldose sugar, that is the carbonyl compound found in position number 1, reacts with what? With the terminal alcohol here. This is the terminal alcohol on carbon number 5, right? Whenever they react with each other, they form what? They form EMIL FISCHER, right? They form EMIL FISCHER. And in that case, you're going to have something like this whenever they react. So in that case, a molecule of water is actually what? Is actually removed, but I'm not reacting them now. So I'm just basically showing you the reason why we have the EMIL FISCHER and also what? EMIL FISCHER, right? So now let's go ahead. So from here now, we have the structure of what? Of glucose in pyran form. Now let's go ahead and fill everything with hydrogen. So we have hydrogen here and also what? Hydroxyl group here. Then here we're going to have hydrogen is here. Then we're going to have what? Hydroxyl group here. Now look at this. This is carbon number 1, right? Carbon number 2, 3, 4, 5, and also what? 6. Since this is carbon number 1, look at this from here, right? I'm having the hydroxyl group here and also what? The OH group here. Then from there, I'm having carbon number 2. Position of carbon number 2 is at this side. So that's why I'm putting it here. Then I'm having hydrogen here. That's why I'm putting what? I'm putting it here. Now look at this carbon number 3. The hydroxyl group is what? It's at the left side. So that shows that whenever I want to write, I'm going to put it here on the top here. Then I'm going to have what? Hydrogen here. Then another thing that you need to know is that this is carbon number 4, right? The hydroxyl group is what? Is here, right? While the what? The hydrogen group is what? Is here. And one thing that you need to take note of is that whenever you are drawing the structure, make sure that the bond is connected to what? Oxygen. Those one of the hydroxyl group, the bond is connected to what? To oxygen. It is very, very important that the bond is connected to oxygen, because no bond is formed between carbon and also what? Hydrogen. Whenever you are, as far as this hydroxyl group is concerned, right? Bond is formed between carbon and oxygen, and also what? Oxygen and also what? Hydrogen. Do you get it now? Now let's move to what? To the last carbon here, which is what? The carbon number 5 here. Now we are going to have this. We have this here. So here we are going to have what? Hydrogen here. We are going to have hydrogen here. Exactly. So because the reason why we are placing hydrogen here and not hydroxyl group is because don't forget that this is what? This is the terminal carbon, right? The terminal carbon which carries what? Hydroxyl group. So the oxygen here, it has actually reacted with what? With the oxygen that come from here. I'm going to be removing the molecules of water. That shows that I'm going to be removing what? I'm going to be removing H2O. That's what I'm going to be removing. And in that scenario, once I remove H2O, I'm going to remove what? This oxygen. This oxygen actually comes from what? From this oxygen that is here. That's why you are having this one to what? To be hydrogen. Now, what is the name of this particular compound is called? It is not just called glucose. It is called D-glucose. And this is why I'm calling it D-glucose. As far as this guy is concerned, it is D because the carbon number 1 oxygen here, which is the carbonyl compound, reacts to the terminal hydroxyl group. The terminal hydroxyl group that it reacts with is found what? On the right hand side. And don't forget, whenever an hydroxyl group is found on the right hand side of carbon number 5, it is referred to